Hi there, I'm Evelyn, and welcome to my channel. Today, we're skipping the fluff. We are not talking about what OpenClaw is, and we definitely are not touching Notebook. Instead, we're diving straight into the how. I'll share how I set up OpenClaw entirely with local LLMs via Ollama on Linux. No API keys, no cloud-based services, and minimal data leaving my desk. Local LLM, local agent, and local tools. Installing OpenClaw and Ollama is easy. Making them actually usable is the hard part. If you've tried this, you know the frustration of your model hallucinating tool calls that don't exist. I'll also show you a hidden default in Ollama that acts as a massive bottleneck for OpenClaw. I'll walk you through how to bypass that 4K token cap so your agent can finally see the big picture. Let's dive in. Now, the community loves the Mac Mini for its unified memory architecture. Since the CPU and GPU share one big pool of RAM, you can load massive models that would normally choke a consumer GPU. Does it have to be a Mac Mini though? Definitely not. The UMA advantage only matters if the model lives on that specific machine. If OpenClaw is just the agent calling Claude Sonnet, GPT 5.2 or Gemini 3, a mini PC can be a great option too. My setup is the Aoostar Mako Mini PC with an AMD Ryzen 7 6850H CPU, 24 gigs of soldered LPDDR5 RAM, and very importantly, OcuLink support out of the box. In order to run a local LLM, I've paired it with an external RTX 5060 Ti GPU with 16 gigs of VRAM on a Minisforum DEG1 dock and a silent ATX power supply. It's a beast, but it stays quiet. A quick pro tip here. Plug your HDMI or DisplayPort cables into your motherboard or mini PC, not the GPU. Let the integrated GPU handle the desktop while the dedicated graphics card stays 100% focused on AI. VRAM is liquid gold. Don't waste it on your monitor. We're starting with a fresh Ubuntu 24.04 LTS install. We'll mostly just follow the standard installer wizard, choosing the default selection which gives us the minimal installation. We want this environment to be lean and mean for our local LLM stack. Once the installation finishes and you've rebooted into your clean desktop, we're ready to get those NVIDIA drivers talking to the hardware. It's always good practice to ensure your system is up to date, especially after a fresh install. We'll bring up a terminal window and run sudo apt update and sudo apt upgrade. Since I'm using OcuLink, the OS sees the GPU as a standard PCIe device. Installing NVIDIA drivers is straightforward, just like an internal card. We'll run the adapt repository command and sudo apt update to add bleeding-edge NVIDIA drivers to my system's list of software sources. We then run sudo ubuntu drivers devices to find available versions and install the recommended one. Once the drivers are in, run NVIDIA SMI in your terminal. You should see your GPU listed and the VRAM is sitting empty. Head over to Ollama.com and grab the Linux install command. It's a simple one-liner. Once that's done, we need to pull our models using the Ollama pull command. In this video, I'm testing GPT-OS S20B and Qwen 2.5 coder. Once the models are downloaded, it's time for a health check. Go to localhost 11434 in your browser to confirm Ollama is alive. Then, check your models at the /v1/models endpoint. Finally, let's test the actual inference. Fire off a quick post request to the API with a simple prompt like, "Why is the sky blue?" If it responds, your local LLM engine is officially humming. Now for the main event. Grab the OpenClaw one-liner install script from their site openclaw.ai. The installer will detect the environment, install Node.js if it is missing, download and install the latest OpenClaw release. Once these are done, it will automatically run the onboard wizard. We'll select yes to acknowledge that we're doing something dangerous. We'll choose the quick start onboarding mode. Then we'll do skip for now, because the wizard doesn't list Ollama as a provider, and we'll pick any model as the default model. We'll fix all of these in a moment. We're skipping channel setup, skill configuration, and hook enablement for now too. When asked, how do you want to hatch your bot? We should choose do this later because we haven't connected our model to OpenClaw yet. Now we'll go to the primary configuration file, OpenClaw.json, which is stored in the .openclaw directory, a hidden directory in the user's home folder. I initially tried editing OpenClaw.json by hand, but there's a cleaner way. Use the command Ollama launch OpenClaw config. This hooks them together using the latest integration support. In case you already have Ollama on your machine, you'll need v0.15.4 or higher for this command to work. Now let's open up OpenClaw.json. We can see Ollama being added as a provider. API is set to OpenAI completions because OpenClaw uses Ollama's OpenAI compatible endpoint. Base URL is pointing to my local Ollama instance, and there is also a dummy API key Ollama local. We also find model definitions for the two models I just pulled. Lastly, Ollama has also set the primary model the agent uses for thinking. Enabling tools and hooks is vital. I also set up Chrome and seerxng via Docker for browsing and searching. Built-in search usually wants a Brave or Perplexity API key, but we're staying 100% local for maximum privacy, hence seerxng. Now open your browser and navigate to localhost 187.89/config. We'll do the rest of the tooling setup here. Everyone's workflow is different, but here's my Goldilocks setup. In the Tools section, enable web fetch but kill the built-in search. Since we're going API key free, seerxng will handle the heavy lifting. For the browser, I set OpenClaw as the default profile, and I'm pointing the executable path to Chrome, but feel free to use Brave or Chromium. Finally, under plugins, I enabled LLM Task, Lobster, and Memory Core. Run OpenClaw Doctor and OpenClaw Status-all to check everything. You should be able to use the Web UI or Terminal UI to chat with your OpenClaw agent now. However, if you're like me, this is where things might start breaking. OpenClaw is a beta that has 4-digit open issues at this moment, and I ran into an issue where prompts returned raw JSON instead of calling tools. I had to use Jokelord's hot patch to fix the tool calling logic. It's a band-aid, but it worked for me. Next issue, the LLM was hallucinating tool names, like browser.run. It turns out there was a massive context window mismatch. Even though the model supports 128K tokens, Ollama was capping it at 4K. Ollama show command tells me that the GPT OSS model's theoretical maximum context window is 131,072 tokens. When the model is actually running, I see the actual context window was only 4,096. OpenClaw relies heavily on large system prompts containing multiple markdown files, including tool definitions. If the context is truncated to 4K tokens, these critical instructions for tools are likely cut off. The model literally forgets how it's supposed to talk to the tools and starts to guess. To fix this properly, I created a persistent custom model. Step 1 is writing a model file where we define our base model and manually set that 128K context limit. Then, use Ollama Create to build this high context variant. Lastly, I updated OpenClaw.json to point to this new model ID. Now, the agent has enough context window to read the full instructions from the system and execute tools reliably. OpenClaw with local LLM isn't exactly plug and play, as we've seen, but the sovereignty we gain is worth the effort. We've got hardware isolation, a brain that doesn't phone home, and enough context to actually remember the mission. Thanks for watching the setup. If you ran into different errors or found a better patch for tool calling, drop a comment below. I'll see you in the next one.